series of alcohols. Observe the table. In this table, the molecular formula of methanol is CH4O. Condensed structural formula of methanol is CH3OH. In this condensed structure, we are able to determine the number of carbon atoms, that is 1. Number of CH2 units are found to be 1, and boiling point of methanol is 63. Second homologous series of alcohol is ethanol. Molecular formula of ethanol is C2H6OH. Its condensed structure formula is CH3CH2OH. In this condensed structure, 2 carbon atoms are present and 2 CH2 units are present. The boiling point of ethanol is 78 degrees Celsius. Now let us begin. Now let us see the homologous series of alkenes, that is ethene, propane, butane, pentane, and so on. The molecular formula of ethene is C2H4. Its condensed structural formula is CH2 double bond CH2. In this structure, we are able to calculate 2 carbons are present and CH2 units are absent. Its boiling point is -102 degrees Celsius. Second example of alkene is propane. Its molecular formula is C3H6. Its condensed structural formula is CH3CH double bond CH2. In condensed structural formula, we are able to find 3 carbon atoms and 1 CH2 unit. The boiling point of propane is -48 degrees Celsius. So this is all about the homologous series of alkene and alcohols. If we study these tables, we are able to understand that while going in an increasing order in any homologous series, the physical properties shows variation in one direction, that is, graduation is observed in physical properties. The molecular formula of members of homologous series of alkenes can be represented by general formula CnH2n. When the value of n is 2, we get the molecular formula of first member of this series is C2H2 into 2, that is C2H4. The general molecular formula of homologous series of alkynes is CnH2n minus 2. While going from one member to the next member in the homologous series, one methylene unit gets added. Molecular mass increases by 14 Dalton. Number of carbon atoms increases by 1. Chemical properties of homologous series shows similarity. All the members of homologous series can be represented by the same general molecular formula. Hello dear children. Now we are going to learn about the nomenclature system of carbon compounds. We have already studied that millions of carbon compounds are known. Initially, when the known carbon compounds was small, the scientists named them in a variety of ways. But now, the carbon compounds are more, so it is very difficult to give a name. Just like, for example, the source of the name of first four alkanes are methane, ethane, propane and butane. Two isomeric compounds having a straight chain or branched chain in their structural formula are possible. For the molecular formula C4H10, let's begin with the IUPAC nomenclature system. IUPAC stands for International Union for People and Applied Chemistry. IUPAC system is based on the structure of the compounds. IUPAC nomenclature is accepted all over the world. There is a provision in IUPAC system for giving a unique name to all the carbon compounds. There are 3 units in IUPAC name of any carbon compounds, nothing but parent, suffix and prefix. These are arranged in the name as prefix, parent, suffix. IUPAC name is given to a compound on the basis of its parent alkane. The name of the compound by attaching appropriate suffix and prefix to the name of the parent alkane. The steps in IUPAC nomenclature of straight chain compounds are as follows. Step first. Draw the structural formula of the straight chain compound and count the number of carbon atoms in it. The alkane with the same number of carbon atoms is the parent alkane of the concerned compound. Write the name of this alkane. In case of carbon atoms or carbon chain is concerned, the compound contain a double bond. Change the ending of the parent name from its ANE to ENE. This is the first step for IUPAC nomenclature. The carbon chain is concerned which contain a triple bond. Change the ending of the parent name from ANE to YNE as shown in the table. Second step. If the structural formula contains a functional group, replace the last letter E from the parent name by the condensed name of the functional group as the suffix. Exceptions are the condensed name of the functional group halogen is always attached as the prefix as shown in the table. Third step, number the carbon atoms in the carbon chain from one end to the other end. Assign the number 1 to the carbon in the functional group CHO or COOH. If numbered in two directions. Accept that numbering which gives a smaller number to the carbon carrying the functional group in the final name or digit and a character should be separated by a small horizontal line as shown in the table. Usually, numbering is not required if the carbon chain contains only two carbon atoms. Some more steps are required for writing IUPAC names of compounds having more complex structural units such as branched chain, carbon rings, heterocycles, etc. A study of these will be included in the further standards.
Of branched alkanes. Hydrocarbons contain only hydrogen and carbon. A saturated hydrocarbon is a hydrocarbon in which all the carbon-carbon bonds are single bonds. Such saturated hydrocarbons are called alkanes. Each carbon atom forms single covalent bonds with hydrogen. Naming organic compounds is called the IUPAC system. The initials signify the International Union of Pure and Applied Chemistry, which is an international body to set standards for chemists. In the IUPAC system, naming the branched chain alkane is based on the longest continuous chain of carbon atoms in the structure. The branched chain alkanes are named according to a sequence of steps. Look at this simple example. Identify the longest continuous chain of carbon atoms in the structure. There are two possible ways to number the longest chain, from left to right and from right to left. In this example, in either instance, the longest chain has 3 carbon atoms. Therefore, the prefix will be prop. There are only single bonds between all the carbon atoms. Adding the suffix "ane" makes the name of the longest carbon chain and called propane. Name the branches or side chains. The branch or side chain in this molecule is CH3. It is methyl group. Number the longest carbon chain so that the branch or side chain is attached to the carbon atom with the lowest number. In this example, the branch is at the second carbon in any instance. Start the name with the position of the branch, which is 2, and the name of the branch, which is methyl. The beginning of the molecule's name will be 2-methyl. The complete name of the branched chain alkane is 2-methyl-propane.
Hello dear children, let us begin with the chemical properties of carbon compounds. First property, combustion. Let us first look at combustion as a chemical property of carbon compounds. We have already studied in previous standard that carbon in the form of various allotropes on ignition in presence of oxygen undergoes combustion to emit heat and light and forms carbon dioxide. Hydrocarbons as well as most of the carbon compounds goes combustion in presence of oxygen and emits heat and light as well as the carbon dioxide and water as the common products. Some of the combustion reactions are as follows. In this reaction, carbon combines with oxygen to form carbon dioxide, heat and light. In second equation, CH4 plus 2O2, in this reaction, methane combines with oxygen and produce carbon dioxide, water, heat and light.